mentoring training on the topic prototyping, proof of concept, and product development. My name is Julia Bauer, and I'm project manager at Accent Incubator, which is an incubator based in Austria, focusing on bringing deep tech startups on the markets. And I'll be guiding you through today's session. Yeah, before we start off, I would like to give you an explanation of the experts and facilitators that we have here today. So our first expert is Stefan Stadelbauer, an entrepreneur, inventor, mechanical engineer, and technical chemist. With Protovation, he has led the development of prototypes, PoCs, and pilot test plans that bridge science and practical engineering. His team works on reactor systems, reaction processes, nanomaterials, and energy technologies, translating complex concepts into robust, testable systems. And today, Stefan will share what it really takes to move from PoC to prototype, including real-world hurdles and how focus and disciplined project management turn ideas into working hardware. So that's Stefan. Our next expert is Bernhard Pichler, a biotech scientist and engineer who began developing an electronic nose, an e-nose prototype at the Austrian Institute of Technology in 2020, together with a research team. And he has since overseen the data engineering and software needed to digitize smells from the very first prototype to today's systems at NOSI, which stands for Network for Olfactory System Intelligence. And Bernhard will walk us through the hardware, software co-design behind reliable e-nose setups and how deep tech projects make the leap from research to applications. And we are also very proud to be able to say that NOSI is an alumni of our deep tech incubator here at Accent. And finally, our third expert is Clemens Meyer, a prototyping and compliance specialist and certified CE product coordinator. He works at the intersection of hardware development and regulation, helping teams integrate CE GPSR requirements right from the proof of concept stage. So Clemens focuses on practical, low friction compliance, what to do early, how to avoid costly redesigns, and where to find reliable guidance when standards and testing become complex. So now I'm very happy to start with our first input today. In the opening lecture, Stefan Stadelbauer will walk us through how prototypes evolve from proof of concept to market-ready MVP, and what common mistakes to avoid and how to build the right mindset for prototyping as a deep tech entrepreneur. So Stefan, the floor is yours.
Thank you, Julia. Nice to be here and to give some information to you. But I'm not only tell you something about how to make good prototypes. As I'm an entrepreneur, I know what it takes. It's also very important to set or to get the right mindset. So I will also talk about this. So who am I? I'm Stefan Stadelbauer. I'm a scientist. I'm an engineer and an entrepreneur. So I'm not a business guy who typically are those who tell you how you should run your business. I'm one of you. I also had a journey that is similar to yours, maybe. So I started as an engineer, then I became a scientist, then I had to experience the hard world of entrepreneurship in the fields of technical chemistry and mechanical engineering. And so, as I already mentioned, the content of today is not only about prototyping, it's also about helping you to get the right mindset. I think it is very important to know this. Then we go into detail on proof of concept, prototype, and developments of products in general. Then typical pitfalls which you should know then because you can avoid them. I had to run through all these pitfalls. Then how to overcome the pitfalls. Then why prototypes are really important, spoken as a guy who is doing a lot of prototypes. And then more out of our prototyping world. So one question I was asked a long time ago when I was starting my entrepreneurship route is a very important question, and I also want to ask you this question. And the question is, what you need to know as a deep tech CEO, and the question really is, what do you think is the most important task of a CEO? Finally, all of them are important, but at different phases. So depending on where you are in the journey, you should focus on different answers. And if you now have a look at the standard journey of a company, Julia, you might switch. Then you see this diagram here. It's a loss margin diagram over time. When you start a company, typically you invest money, you generate loss over several years, for example, and after some time you get some revenue and you generate margin. So this is a typical financial journey of a startup. And depending on where you are on this route, different things are necessary. And if we now release it, then you will see that, for example, having a good idea is very important right from the beginning. Having a good product like answer number one will be important in the later stage, but it will not be important at the beginning. While answer number 5, not running out of money, is more or less all the time important. And so depending on where you are in your journey, as we saw right from the beginning, there are different stages. There are some ones who didn't found, there are some ones who think about to found a company, and then there are some ones who already want to build a prototype on TRL 4, as I wrote. So based on your journey, based on the status of your journey, you need to focus on your task, on your most important task. So build your focus accordingly, depending on your journey. This is a very important thing you should keep in your mind. If you are right at the beginning, do not waste time on having a good product. This will not bring you anywhere. You have so many tasks to fulfill, and you really need to focus on, depending on your status in your founding route, on the necessary things. I hope this gives you a small guide, a guidance in your current situation. Then now let's come to the family of prototyping. There are mainly 3 types of prototypes, and they are always intermixed with each other. Some talk about proof of concepts, the other ones talk about minimum viable products, then some others always talk about prototype regardless where they are in their journey. And there is a ratio behind these 3 names, and you should know it. So everything starts typically with a proof of concept, which more or less is proving that your idea is technically feasible. And then comes the second stage, that's actually called the prototype. And this is then a demonstration of your technology in real-world condition. So if you have a reactor using different materials as the educts, then real-world educts would be impure educts, for example, rather than pure educts as you are typically used to use in a chemical lab. And then there is number 3, it's called MVP. This is the minimum viable product. And this is then a sort of first kind of product, which is still not perfect, but which can be given to the market and where customers can gain their first experiences with it. And they bring back to you the knowledge if the product works or if it does not work or what to be optimized. So these 3 types of prototyping you should have in mind, and you should know what it is. Because if an investor asks you, do you have already an MVP? You should know what it means. because then you could answer, no, we don't have an MVP because we didn't even have a prototype yet. So if you know these three sorts of prototyping, then I think you better understand the journey to your success. And to make you better understand these differences, we go now through all the stages according to a series product from our company, which is the HeatX pump. The HeatX pump was developed by Protovation, and it is a thermodynamic machine suitable for universities and higher educational schools, and it is used to teach thermodynamics on the current state of technology and beyond. That means it has a digital intersection, so that you can also play with digital twins or with smart building integration and so on. So we were asked to develop such a machine. So the customer came and he had an idea. And it was not clear that if it works at all, because the task was to make such a machine on a small lab scale. It should be mobile, it should be safe. So it was more or less a bunch of tasks the machine should fulfill, although we don't even know if we find the right components, if the whole process works on such a small scale. And that's why we started with a proof of concept. So the proof of concept is a Spartanic first prototype that just shows the technical feasibility. And you will face in your journey many problems during this proof of concept phase. So if you look, for example, to the center picture here, you see that this black vessel in the front is totally frozen. This was for us really a situation where we were encountered with the fact that it does not work the way we wanted it to work. So we had to run some adaptation rounds. Finally, we needed a bypass with some check valves in order to overcome these problems. And you, on the right side, you see these adaptations. And if you now look to the left side, to the Spartanic product, you see that we have weird cable situation. We have only a 4-line LCD display. We don't have a nice LCD display. It was really just a proof of concept which shows that it technically works. And upon having reached this situation, we went on and produced the prototype. And the prototype is now defined as a stage of your product where it's technically working. As you see on these IR pictures on the left, you see the bigger one, which is heating mode, where the black vessel in front is orange and the evaporator on the backside is blue, so it's cold. And when you switch the operation mode, then suddenly the vessel becomes blue and the evaporator on the backside becomes yellow, indicating that we have now changed the process of operation. So it is totally working fine in the prototype phase. But now you have to also work out the user interfaces. Because one of the most important things of a prototype is that you can reach out to customers, to first potential customers, and convince them that your product could be beneficial for them. So, and for this, also the human device interfaces need to be somehow developed. Now we lost the presentation, Julia. Now it's back again, okay?
Fine.
And when you have done the prototype, then you can start making a minimum viable product. And there comes a whole bunch of other tasks to your desk, meaning market permission. A minimum viable product is a small amount of your products being sent out to customers. Customers can work with this product and they will give you feedback on the product. But in order to be able to send them out to the market, you need to have market permission. You need to have declaration of conformity in European Union, for example. And for this, you need to finalize the product. As you see on the left picture here, we have some white shields. These are some protection shields that no one can get burned by the pipes. Then in the middle, you see we have made some electromagnetic, how is it called? Electromagnetic persistence tests in order to follow the EMV directive. And then the machine is ready to be sent to the customer, and then you can get feedback. So it would be totally worthless if you do such white shielding on the stage of a proof of concept. It will just annoy you. Or also running EMV tests in the proof of concept phase would be waste of time. You should know what will come up later, but you should not invest time in such things at the stage of a proof of concept. So I hope this is now somewhat clearer to you. What is the difference between a proof of concept, a prototype, and an MVP? And each stage of these three is important, and each stage has its own requirements. And to strengthen what I have told to you, I show you some other examples. Here, for example, we have made a 10-liter bioreactor for a special fermentation reaction. We did not know upfront if the whole process worked, so we made a proof of concept. The proof of concept can be seen on the left side. It is really, how to say, it's looking ugly, I would say. We just put together all the components and we tested them. We didn't invest time in making proper cabling, as you see here. And then finally we found out that it is working, or that we had to adapt some things. And finally we went on to the prototype stage, and we built the prototype now, which can be seen on the right side. You see it is much more tidied up. There are certain geometries, I would say. The cabling is nice. There is already a lot of, there are two displays in it, so the human device interface was also done already. And I hope this shows you the difference clearly between proof of concept and prototype. Then there are some others. Here you have a proof of concept of a special vanadium redox flow battery. We just quickly put together vessels, a stack, a pump, and checked whether it works. So it worked. And then we went on and made a stack of it. Also another stack is shown here. This was an alkaline electrolyzer stack used for 3D printed electrodes. So we didn't invest much time on making a proper product. We just quickly made a proof of concept and checked whether the technical terms are doable or not. Another example are this carbon dioxide reduction reactor platform, which is now a prototype. It looks very nice, as you see. It is well deformed. It has a user interface. It has already safety systems, as you see by these two orange and red lights on the left side. Then on the middle side, this is now the prototype of the alkaline electrolyzer setup from before. So before you saw the proof of concept, now here you see the prototype. And on the right side, you see another example of a prototype. This was a machine we produced for a startup who wanted to put the prototype into a digester of them. So this already, again, has a nice orientation, has a good human device interface, and it also has a good program code, so it works kind of automatically, while the proof of concept does not at all work automatically. I hope this has become more clear to you. What is the difference between proof of concept, minimum prototype, and minimum viable product? And now I want to show you some typical pitfalls, because I was myself a scientist, and I know that scientists typically tend to perfection. And when you start a company, your time is your most valuable asset, and you need to avoid waste of time. And this was a very big learning for me. I was doing lots of nice research in the lab, spending a lot of time. But when I started a company, I had to organize myself and had to focus on important tasks and leave non-important tasks behind. So this might seem clear to you that you have to focus on the important things and don't waste time on not important things. But the question is how to know which things are important and which things are not. And here I want to help you to find the answer to this question. And showstoppers, for example, are very important things. And you should invest time on showstoppers. And on the same hand, you should also identify tasks that can be done later and which are not showstoppers. So this would be a first approach for you, how you could identify showstoppers, so important things, from non-showstoppers, from non-important things. So I would say I had to learn on what I should put my focus on. And this Pareto principle, as it is typically called, is very important for this. Good. Then I was also asked to give a short description of the technology readiness levels. Because if you don't know if you need a proof of concept or a prototype or MVP, you can also use the approach by the technology readiness levels. So typically when you found a company, you start at a TRL of 2 or 3, and finally a good product which is beneficial on the market ends up at TRL 8 or 9. And you need to know where you are in your journey. For example, TRL 2 means the tech concept is formulated. TRL 4 means the tech validation on the lab scale is complete. TRL 6 means the tech demo in a relevant, realistic environment is working, and so on. And depending on where you are on this TRL line, you need a proof of concept if you're between 2 and 4, or you need a prototype if you are between 4 and 7, and you need an MVP if you are above 7. So this could also help you identify what you will need in your journey at the moment situation. Good, and now I'm almost at the end, right? The question is now, why is prototyping important? It's extremely important because it is guiding your direction. If you start with a proof of concept and you find out it does not work, then it will show you this direction. If you wait too long with a proof of concept and later you find out that the proof of concept does not work, you have lost a lot of time. So starting with the proof of concept, which gives you the truth about whether it works or not, is very important because it guides your direction. You immediately recognize whether you have to change direction or not. This is one major important point of prototyping. Also for the prototype itself. The prototype, when you reach out to first customers, will tell you if the customers are interested or not. Think about a situation when you have a prototype and you invite customers, potential customers, and they will have a look at the prototype and then they are not at all interested. You need to know this early on because then you can adapt and make another prototype which might be interesting now to other customers. Same is true for the minimum viable product. Customers will tell you what they really need, what is good, what is bad. And so the whole area of prototyping will guide your direction. It's very important for you. Then there is the progressing effect. When you have had a successful proof of concept or a prototype or a minimum viable product, then you build your trust on yourself. You build confidence, and also not for you, but also for your team. So this will help you shaping the team. And the third point why it is very important, that's the attracting investors. In Europe, investors typically want to avoid risk. They want to avoid as much risk as possible. And if you go to an investor when you already have a proof of concept and a prototype, then the investor knows, it's working technically. There are customers who are interested, so it makes sense, or it makes more sense to invest into you as a startup having PoC and prototype compared to a startup which doesn't even have a proof of concept. Because the risk for an investor is much lower if you have run through this prototyping stages already. Yeah, with this,
maybe ask a question in between?
Yeah. I'm already at the end here, so
okay.
so sorry. So we could, if you give me 30 seconds, then you can ask your question. So with this, I'm at the end. You feel free, please, to contact me if you have any questions or interesting projects also. And now, Mr. Don van Els, I don't see the full name.
Yeah.
Please go ahead.
Yeah, particularly on the last slide, because you mentioned indeed that investors are very interested to see your prototypes and MVP, but also we found particularly if customers pay for it, so if they show financial commitment. So, but do you see a particular stage from which it's important to ask customers also to pay? Because you can have projects with companies at TRL 5, but also at 6, 7, 8. In your experience, how do people handle that?
It's a very good question. And it's always depending on you and your situation. For example, for the HeatX pump, when we developed it, we asked the customer right before we started with the work to give a down payment. So we did not do it for free. Of course, the customer was not able to finance the full development costs, but we said, okay, you have to give us 20% of all the development costs, then we will develop the first prototype. You can have the prototype, but we are the product owner, so we can make a series product out of it. So in the case of a HeatX pump, we got payment right away when we started. Same is true for the carbon dioxide reduction reactor. This is such a specific product where we said, okay, we will not develop for you the product without any payment. And here we made a detailed plan, and they covered 70% of all the development costs. So this would be an ideal case. If you always get money, it might not be always true for you. For all of you, you might have to find other ways how to get money, for example, out of public funding or from business angels. But in any case, if you develop something and you have a first customer who is willing to pay something, this is, of course, very attractive for an investor, because it's the best proof of desireness of the product, if there is one who wants to pay for it. Does this answer your question?
Yeah, it helps for sure. I think there's also a difference, of course, for you who develops things for people, and you developing a product yourself that you kind of want tested. But it helps. Yeah, thanks for giving context.
Good. And then I want to also introduce you on my last slide to Clemens Meyer. Clemens Meyer is a partner of mine, and you need to unmute Clemens in order to say something. So I really want to tell you, when you do a proof of concept or when you do a prototype, you have to do it the right way. Because when you want to go to a minimum viable product, you finally have to get market permission. And there are so many directives and regularities in Europe that you really have to be careful not tipping into the pit that you design a product that can never be, certified. Because, for example, if you check out the pressure directive, where you need to stay below 100 bar liters. So if you know you have a pressure device, you should design it in such a way that you don't have to fall in all these pits which coming along the certification process. And there are some specialists like Clemens Meyer who can advise you, helping how to design the product in a proper way so that you later on don't have the problems of a forest of regulations, I would call it.